Hi, everyone. Welcome on our second webinar with the title Selecting the Right Control System. Last week, we had a webinar with selecting the right compressor. I hope you guys attend. If you didn't have a chance to attend the last webinar, you can always join to our webinars on YouTube. We have the channel named Calms, where you can basically find our last webinar and check webinar what we had. If you will have any questions later for the first webinar, of course, you can contact us. But today, our topic will be a little bit different. It's all about the simulations, but we will try to find what is the right control system in CAMS. Today's speakers are Rok and me, Uroš. And I think later, at the end of these presentations, you guys will have opportunity also to ask us if you have some questions about our webinar. Also, I recommend you, if you have any questions before, you can easily type down into the chat box, and then we will read them at the end of our presentation. Our presentation will be around 45 minutes. And the last 15 minutes, we will probably have time for these questions. So let's start. Okay, I hope you can see my screen well. So some facts about us. Firstly, just to introduce myself, I'm Uroš. I work in CAMS for 4 years now. My role here is to be a technical support, and also my specialization in CAMS is our measurements and measurement equipment. And also, I will guide you through, if you have so many questions, you can always contact me via email, and I will try to respond as fast as I can. And on the other side is Rok.
Yeah.
And maybe, Rok, you can introduce yourself.
Right, yeah.
Something about yourself.
My name is Rok. I've been in the compressor business now for just under 20 years. And the last 10 years have been spent at CAMS. My first work was with measurement equipment, and then moved on to audits. And now for the last 8 to 10 years or so, I've been working on this platform CAMS. Yeah, that's it.
Cool. Oh, thanks, Rok. You will have a chance later with your presentation. Maybe show us a practical example how you can choose the right control system. So let's go back to the presentation. So some facts about CAMS company. Probably, guys, you already heard about us. If you didn't heard, I will just let just few main points of our company. We were established in 2008. There were like a group of team of experts establishing this, and of course, we developed this application with software developers. And also some other guys from mechanical engineering background, electrical engineering background helped to develop this application. The main point of our application is to have a holistic approach to optimize compressor system. Also, about our company, it's important that we are completely independent independent company. So we are not connected to any manufacturer of different equipment. Also, what is good for our company with CAMS company, that is compressor management system. We provide you different compressor management solutions, also such as improvements with the action cards, with our AI, basically, which automatically show you where you can improve your system. And also there is a group of independent experts who are also using our application. What is good to mention is that our application is supported by different standards. So from standards for CSA 37 for monitoring, then we support also different standards, ISO standards, such as 11011, We support waste management, 50,001 energy management, and also 55,000 we support asset management. Also, something what was established this year is CATS coalition, and this means that CATS is also supported by this coalition, which is independent experts in one coalition from all world. So these are some facts about us. Now, if we continue to the main point, the simulation, why we are here. So some theoretical part of the simulation. The simulation basically is the process of transforming the real system to the computer model. What we developed is that we also developed in CAMS that you need to have also a lot of mathematical equations to describe the flow, power, and pressure characteristics. This simulation will basically provide you insight into the performance, efficiency, and also some potential issues that you can have in your system. Really powerful tool for optimizing the system design, reducing energy consumption, and also enhancing overall functionality. So what kind of simulation we have in CAMS? We have different type of simulations. For majority of them are you can use them in different fields. First, we have also basically you can use our simulation that you can understand your compressor system. Then the most important part is that you can test your measurement equipment and basically verify if everything is okay with your equipment. You can do the digital twins for digital twins. Basically, you can make a digital twin and decide before you even start, if you will make a new, let's say, investment, you can basically simulate this and see if this will be, let's say, a cost saving for your compressor system. Then you can also, if sometimes, if there is like increasing and decreasing compressor on the demand side, you can always simulate how this will affect in your system, so you can increase or decrease the compressor in your system. Then, for example, for buying new equipment, you can even decide with our simulation tools, you can decide if you will buy different type of compressor. You can simulate different compressors, dryers, receivers, how they affect in your system. Also, what is available is that you can replace basically whole system with a new one. This is quite advanced tool, and more or less a lot of experts already use this simulation in our system. And then we have also where the part where you can basically set and test different control systems and flow controllers in our system. So which we will also talk about this later in our presentation. So these are basically how you can use CAMS simulations. So now for every feature, of course, we know that there are some limitations, and it also comes, let's say, simulations have some limitation on different parts. The main part what we see is the data quality. We always see that there is problem with the measurement equipment that is installed in the different systems. It can be a problem. It's, let's say, with some sensors that are basically giving you, let's say, garbage into your system, and then you basically get the garbage out. So that means that you will do the simulation with the wrong data. So this is what we see the biggest problem on implementation when you are doing the simulation. Then the model quality, of course, it's always important to enter the right data for different equipment to get the right technical data sheets from, for example, for the compressor and so on. And of course, these data need to be accurate enough so you can do the simulations, the data there that are in the data sheets. And then the last part is the understanding the results. There is always what we see that the simulations are quite, let's say, quite very hard to understand in one way for the benefit user. So it's always good to have, let's say, some experts which are already like a few years doing the simulations and they can understand this kind of simulation, they can help you to understand this data. It's really hard to get, I mean, you can collect all the data, but if you don't understand and if you don't know what to do with this data, then sometimes these simulations are useless for the, let's say, normal basic user. So these are the limitations. Let's continue. So how you are doing the simulations in the comps? We divided this to the 6 steps. So in every step, there are different points that you need to cover. And first step is you need to create compressor model. So basically, when you approach one system, you need to do the system review. You need to check the system from the efficiency, reliability part. Then you need to do pipe and instrument diagram, where you draw all, let's say, all plant from the production to the demand. And you need to, of course, here also add some details from the data sheets so you can understand your system. The second step is collecting the data. So usually when you are collecting the data, you collect them with data loaders. What we have in the cloud, you have different variety of data loaders. So you do the temporary, you can do the temporary measurements. When you are doing audit accounts, we recommend that you do around 1 or 2 weeks of measurements, because this is then enough to create a successful simulation. Or, of course, you can have permanent monitoring, where you can basically choose different time period which you want to analyze. Yeah, of course, if I continue, the third step is select right simulation period. Of course, you will have a lot of data, and you know that you have in the compressor systems, you have, let's say, during the day you have normal shift, and then during the night you have shifts that are, let's say, different than during the day. So it's really important that you choose right simulation period, because with the right simulation period you can also get good simulations and the results. Then you are verifying the model. So you can simulate existing compressor system model and verify result with the real system measurements. It's the 4th step. And then the 5th, you compare the results. So you can run many simulations and compare existing system or systems between each other. So there are these different varieties how you can use this, let's say, you can use these simulations. And then at the end, the final, where probably you will create some report, is that you are selecting the best simulation what you've done. You can validate this with experts, which I already told you. So it's really important to do this. And then you can, of course, give this report to someone who will decide for other, let's say, investments. Okay, this is a graphical diagram. Basically, it's similar that it includes the similar steps that I already described before. So let's say on the step here, of course, we have the plant. You have compressor room there, then the production and so on. You will set some measurements there with some measurement equipment. Everything is connected then with our edge devices, with data loggers. The data there is streamed to our cloud. And in cloud, of course, then when you have data there, you need to start analyze this. Of course, you can include independent experts, or you can do analyze by yourself if you are an expert. Of course, you need to validate the data and see if everything is with what I already told you before. It's important to check the data, to have that you have the right data and it's good data. Then you continue with let's say know-how. You will run the simulations. With simulations, you will receive let's say auto analysis we do for you, and also some simulations, and you will receive the action cards and the recommendations, which will help you. Basically, they will show you what are the potential savings in your system, and of course, with your action cards, you will then start with implementation into your plant. So you can see it's basically it's a circle of different actions. And if you follow this, let's say our circle, you can have successful simulation, and you can your plant, your compressor system can be well optimized and have a lot of savings. So I think this is a really good graphical part where you can see how the simulation works. Let's continue. Now I will just shortly go and explain how basically collect the data from the plants. So basically, let's say on the left side, again, we have the plants. We can have here then different measurement equipment. Maybe what I didn't mention that comes, you can use different measurement equipment for different brands. You just need to have most common protocols such as Modbus, analog, OPC. So you can connect flow meters, flow controllers, pressure sensors. Everything is connected to our data lodgers for monitoring. Then we have also audit lodgers, the smaller one, the bigger one for controlling. And from here, everything, all the data is transferred to the cloud. It can be also transferred to the customer cloud or to the cloud that we use. So we use Amazon servers, and there then the data is transferred from there, is transferred to the Calms platform. So on Calms platform, we develop also different views. You can use a corporate view. So if you have multiple plants, you can check all the plants all around the world, how they are, how they are going with your KPIs that you decide. Then you have operational view for one system, and also the expert view, which allows you to do the simulations. What I didn't tell you is that we also included the leak management part, so you can also do the leaks with our application, and you can use also our mobile app where you can find the leaks and transfer to our software. Okay, so now I think it's the time where we need to move to a more practical part. We will show you now on the real example with the real data, how we do simulation and how we choose the right control system in one of our demo systems. So excellent. Let me just stop share this one, and I will start sharing another screen.
Okay, so last time we simulated the purchase of a new compressor in a compressor station. The compressor station was not running efficiently at all. And we exchanged one of the compressors for one of the on-off compressors for a new VSD compressor that we picked from our database. And today, we will not be buying any compressors. What we will be doing is we will be trying to add a controller. So first we will simulate these compressors running on-off, just as they do in real life, and then we will add a controller and see if we cannot improve the situation. The simulations are under the analysis and I've already created a slice, as we call it. I chose a slice of a duration of 1 day, a typical day, and we will simulate the running of the compressors during this day. First, we have a look at the actual measured data, and just like last time, I will delete the measured data. We'll renew the measured data, so we have a look at how that is done. We choose the measured data that we are going to show. We will show the flow channel, which in this case is system flow, and the pressure channel, which is the system pressure. We will show both compressors. There are 2 on-off compressors working at this site. And that's all we need to do to have a look at the running of the compressors. And right now we see a typical graph of the 1 day running of the compressors at an aggregate of 1 minute. We have the pressure here in magenta. We have one of the compressors in red. We have another compressor here in yellow. They're both on-off compressors. And we have the flow here in blue. And if you're wondering why, even though this is an on-off compressor, it may look like a VSD compressor, this is because of the aggregates. If we have a look closer at the data, and we will zoom in as soon as a much finer grain data gets pulled from the cloud, we will then zoom in and have a look at 10-second data. Here we go. Sometimes it takes a bit longer, but as you can see, as we zoom in, the pressure is fluctuating. It's the on-off compressors, and that's the power of one of them. And the yellow is the power of the other compressor, and the blue is the flow. And as we can see in this graph, the blue flow is very spiky due to the fact that the flow meter is actually placed before the receiver tank, and therefore looking at the flow, we do not get a perfect picture of the demand side flow, but more of the production side flow. And when simulating simulating how the compressors are going to react to the demand side flow, we first have to create the demand side flow, which is what we are going to do now. So I'll reset this zoom, and we will have a look at a new simulation. And for this simulation, we are going to choose this exact flow. We'll go into advanced options and see in the graph that this flow is extremely spiky. This is not the actual demand flow, but it is the production flow, and it's affected by the turning on and off, by the loading and unloading of the compressor. And if we fed this into the simulation would have no choice but to turn on or load one of the compressors at these exact times, which is not what we want. We want the simulation to run the compressors for the demand that is in the plant, not the production. So we can do that by smoothing out our data. One easy way of doing that is to increase the aggregate, where we have a measurement point we have the average of 10 minutes as a measuring point, and now the flow over the course of this day has smoothed out nicely. And for our simulation, we will call this the demand flow. Of course, the total flow or the capacity of this demand side over the days is exactly the same. The average is exactly the same. It's just been averaged over 10 minutes. So that is what we're going to use for the flow. We write down the system capacitance, that is about 30 cubic meters. This is something that has been checked already when we've done the assessment. When the assessment and the review had been done, we ascertained that the capacitance, the amount of pressure receivers they have, is 30 cubic meters. This is all in European units. We could change this to American units. At the top here, you have the user settings. I am currently the user, and I use these units. but I could change the units, and you could change the units quickly enough. We can name the simulation. So this, I'm going to try to simulate the original running of this compression station. So I'm going to write this as original. And we will add the compressors. As Uroš mentioned before, the first thing we do is we do the setup and the piping and instrumentation diagram. And from that piping and instrumentation diagram, we enter in all the basic data for the compressors. As this is done, we can fill in the data for the compressor number 1. This is our database of compressors, and other than the KGI and some other databases that we've managed to receive, we also have just the system, which is these 2 compressors that are actually in the compressor station of this system. So we will add these 2 compressors in, and then add the next one. And as the data has been already put in during the setup, which is done here, we have all the data of these compressors. So we know what the power, what the operating power is at the operating pressure, which is 7.5 bar. We know the capacity of these compressors, the maximum power and the maximum capacity of these on-off compressors. We also know what the unloaded power is, the power at 0 flow we have written down. And then we have some default values which can be changed, which is the unload time of the compressor and the pressure drop across the system from the compressor through the filters to the dryer. This is defaulted to 30 kilopascal. Of course, we could enter in any other measurements if we had that. We choose our controller. For the moment, we will add in their local control. Both of these compressors are controlled in local mode, and we could go and check at what pressure these compressors had been running. These compressors try to hold a pressure of about 7 bar. So I will add in a cascade system of 2 compressors. So I can set this one at about, let's say 6.7 as a load pressure, and it'll unload at 7.4. This compressor should load at a higher pressure. So this is going to be our trim compressor. So it'll load at 7 bar already, and it'll unload later at 7.7 bar. If we've entered everything incorrectly, we should be able to save, and that is the case. So let's save our simulation, and it is now stored here at the bottom where we can run this simulation. And if the simulation has, there you go. And we have run the simulation, and the simulation is showing us that the difference between the running of the actual data and the simulated data, there is a difference of only 4%. This may be because the capacitance might be a little bit different to what we have checked in the review. It may be that these compressors are not producing exactly the amount that is still stated on their data sheets because of age, and that can be tweaked, that can be measured, that can be found out why there is a discrepancy. But this discrepancy is not very big. It's a 3% discrepancy. It can be lessened. We can try to find why this discrepancy is. But for today's webinar, we will leave why this is. We will not spend hours figuring this out. It's probably the capacitance of the compressors is not exactly as the data shows on the data sheet because of age.
That's the important step that I discussed with that told you before. That's important to check.
Yeah, that is absolutely correct.
Have the accurate.
We can now try a simulation with a controller. So we can start a new simulation. We will add in the same data. So we will add in the same flow with the same aggregation. Set the aggregation to 10 minutes. So we'll have the same flow profile. We can now name this as, let's say, controller. Controller based. The system capacitance is 30, just as it was before. And we will enter in the compressors using just the compressors that are actually in the system. So we'll choose the first one. And for the second compressor, we will choose the second one. And instead of setting a local controller, we will add a master controller. In this case, a simple master controller, which is the easiest to set up. And this is the one we're going to be using today, where all we need is one set point. We'll use that 7 bar and a pressure offset of, let's say, 0.7 bar, and then the sequence in which the compressors should run. I will set a simple sequence of, I would first like the compressor number 1 to run, and if the pressure drops, the compressor number 2 will be the next to join him. If the pressure is high and a compressor needs to be stopped, I would like them to stop in the other way around. So the compressor 2 will be the first to unload, and then if even that is not enough, the compressor number 1 will then unload. So looking at the start priority, I first want compressor number 1 to start up and load. If that is not enough, compressor 2 will follow. Vice versa, when the pressure rises, the compressor number 2 will be the first to unload, and then compressor number 1. Of course, if there are more compressors, the sequence, the priority sequence is of course longer. It should be just as long as the number of compressors in the system. And if we have entered in everything, this should be okay. And we have not. There is some required fields. Let me see what I have missed. Oh, of course, it is choosing the controller. So instead of having a local controller, instead of them running locally, they will now both be using this master controller, which is named master controller number 2. We can, of course, give this master controller its own name. If we have multiple compressor stations, this could be the name of the compressor station. The name is just a descriptive. And there we go. We can save. And once saved, we run the simulation. And as the compressors were both the exact same, I'll first open this up. So we have a look at how these compressors are running. This is how the actual compressors run. This is measured data, as stated at the top. Below is how the simulation simulates the original running of these compressors, and it is off by about 4%. And then if we decide to simulate the exact same compressors with the exact same compressor station, with the exact same flow, the same capacitance and everything, the only difference is when and how they load and unload. In the first case, they were loading locally. In the second case, they were using a simple master controller. we have, which is not always the case, but in this case, we have a slightly better system than in the case of the original. If I close these off, we can have a look at them closer together. So I have set the measured data to be what I am comparing to. So this is all 0. And then the original simulation should be very, very, very close to 0%. It's 4%. And the controller base is 11.5. So imagining that there is an error somewhere, perhaps because of, as I say, some input error, the compressor capacity is not exactly as the data in the technical data shows. There's an offset of 4%, so we can carry that offset onto here. But still, we see about a 7% savings using the controller, the controller instead of the local mode. One of the reasons why the controller-based system, the way we simulate, is better, is because of the pressure drop. So if we have a look at how we set up our compressors, each compressor has a default pressure drop of 30 kilopascals, which is totally reasonable, as the pressure drop between the compressor and the point of measurement of our system pressure, which is usually the pressure vessel after the compressor station. And as the pressures are set up as local pressures on the machine will actually unload faster than before the pressure actually rises to the system pressure rises to what we had wanted to set in the local compressor due to the pressure drop. This, we're using a master controller, does not happen, as the master controller is actually seeing the system pressure on the pressure vessel. So the compressors will load and unload according to that, and you can hold a tighter pressure margin doing that. And so you have some savings because of that. And of course, with two compressors, it's not so visible, but as you get more compressors, the more compressors you add in local mode, you have, of course, them being in a cascade system, the difference between the lowest and the highest pressure is larger than in the control system. And in our case, this is also true, where in this case, it's 1 bar pressure difference. In our simulation of the controller based, we have a setting of 0.7. So there are some reasons why we have savings, and going through and having a look at visually, just having a look at the different ways the compressors are running. As you can see, this is the simulation of the original. The compressors, because we're looking at the same time slot, they are cycling much faster than they are using the controller. This is because of the pressure drop. And so that is today's lesson about using.
What about the money savings here? You maybe show.
Oh, yes.
You know that sometimes you just want to see what are the savings in the money.
I'm so sorry.
Yeah. So the
Oh, anyway, I should have put that out beforehand. I apologize. Where were we? Oh, yes, the money. Yes. Setting up the price of electricity at that plant at, let's say, 20 euro cents a kilowatt hour, and imagining that the annual operating hours are 8,760, which means that they're running all of the time without any breaks. Then the measured data shows a usage of about 400,000 euros annually. The first simulation of the original shows a bit of a difference, so it's down to 380, and the controller based is a difference. It's gone down a little bit more to 350,000. So to offset for this error, let's say that the difference is between 380 and 350. So we're looking at about a 30,000 euros difference annually because of adding a controller. In this case, quite a simple controller, just for 2 compressors.
Okay.
So that's one of the ways and one of the things that we can simulate using our simulations.
Okay. Thanks.
So that's that's it for
Sure.
for today in the practical area.
Let's go back. Thanks. Let's go back to slides. Okay, so we should stop here.
Okay.
So yeah, basically, these are the steps. If we sum up everything what Rock described you in this nice practical example, so the steps once how you are doing the successful simulation is first step is that you are creating a system. Then the second step, you set up the system with all the data, with piping an instrument diagram. You do the system review and also the other stuff. Then you select the slice with the right period. You start with analyzing the period simulations. You select the flow profile. Then you add the measured data. On the cell set, you verify the model with the simulation. So
yeah, that is one step we could have gone further today doing that.
Exactly. And of course, then starting the new simulation, select the equipment, select the set point parameters, local or master controller, what we've done. Also, in the future webinars, we will also include the flow controller, but for now was only the right control system. And then you copy to many more simulations and create the final report, which is the most important one then for your decision.
Yes. And then a decision for the implementation.
Yeah, exactly.
In our case, where you'd have a 30,000 euro savings potential, it would make good sense to verify the model again, go through it with an expert to make sure that that this 30,000 euro has a high reliability. And in that case, I think an implementation in this case would be a good idea to implement that sort of a controller. The return on investment would definitely be short. A controller together with the instrumentation needed and the installation would certainly not cost that much, and a return of investment of under a year, I think, would be possible in this case.
Okay, this was the last step. Last slide. And thank you guys for being with us. If we have some questions, we'll check now in the chat box.
Yeah, let's have a look.
Okay, this was muted before. Okay, there is no questions for now in the chat box. I see. Okay.
All right.
Okay, there is one.
Okay, so we have a question from Mr. Kiran Panda asking other type of standard features in the master controller. At the moment, with the simple master controller, we have the possibility of course, switching the start and stop priority, the sequence in which the compressors come in. We have the possibility of widening the pressure band. And as a simple controller, we try to keep things as simple as possible, and I think that's it. For another controller that we have, the EMCS, this mimics the controller that is also sold by CALMS. It has multiple flow band start and stop priority sequences. So at a certain low flow, let's say during weekends, some compressors are preferred over others. So at a low flow band, a different start and stop priority will be chosen compared to, let's say, a medium flow band, or if the flow is extremely high. This does help in making the compressor station a bit more effective, especially once you get to know the compressor station. You know the different flow bands, you know which compressors you have installed, and perhaps you know in advance that if the flow is between, let's say, 0 and 10 cubic meters per minute, then the best combination in experience is this one, and then you can force that combination in a certain flow band. And as the flow increases on Monday morning and the afternoons, let's say, you have a different sequence. So you have that possibility. And the last one that we're working on right now is where we will not enter in a sequence, but the size of the compressors. And then based on how fast the pressure is dropping towards the critical pressure where a compressor needs to be loaded or unloaded, then the controller decides, depending on the speed of the drop of the pressure. So yes, a lot of interesting things going on with new controllers.
Okay, we have some other questions.
Yes.
Could you please share your YouTube channel link? Yeah, I think my colleague already shared in the comment section, but yeah, you can type into that.
Thank you, Leon. Thank you, Leon.
So yeah, I think this is the right.
Okay. Another question: can your master controller manage the RPM of the VSD compressor based on air demand? We have this possibility, but a lot of compressors do not have the possibility where you can enter in the RPM. If I understood your question correctly regarding can our master controller manage the RPM, we're talking about the master controller, the actual controller that comes with CALMS, or that you can buy as an add-on with CALMS. Yes, it can. But a lot of compressors don't manage to accept that. So we have to use other methods of controlling the RPM, not directly. But we can do that. Yes, we can. The simulator does not output the RPM. This is not something that was interesting for us as an output of the simulator, although it can be calculated, as everything in the simulation is a calculation. So the calculation of the RPM is also a possibility. That's something that we have not implemented nor have found a need to. Do you want to comment on the next one, the one that you got your
Oh yeah. Okay, Dimitris, thank you. Thanks that you guys liked our webinar. We hope you will join us also to other webinars that we'll have in next weeks. So yeah, sure, we will be in contact.
Okay, and we have another question here. regarding what are the types of compressors that we can add to our control system, the one that we have in CALMS. In the CALMS control system, we can add both displacement and volumetric. So we can do piston, we can do screw, and for the turbo compressors, we have it's not out of the box, but it's custom, and we've done many of those as well. So we can do both screw and display and positive displacement. So both the screw and reciprocating, and of course turbo machinery as well. So yeah, we have experience in all these areas. Okay, it seems to be exactly 4 o'clock. If somebody would like to unmute and ask any other questions, we're open for that. Otherwise, that's it from us today. Uroš, thank you very much for the beginning of the presentation. It was absolutely excellent, and
Thanks.
I hope we managed to convey some new information.
Same. The video will be uploaded on YouTube, and all the details will be described also on the LinkedIn channel. So you can follow us on LinkedIn and try to see also the other webinars that will be in next few weeks, covered by Rok, me, or Gora, so who helps me to present this.
Okay, thank you very much, and thank you for watching, Mr. Marshall.
Thank you guys. Have a nice day. Bye.